Okay, so if we wanted to take a look at how actually to do a factorial, um, it gets a little tricky because I don't want to just give you the answer and here's what to start typing, but it's also one that takes a little bit of thought. So what I thought I'd do is I'd give you some hints through algorithms. Now, actually, if you've completed the algorithm badge number 2, the level 2 star, you've actually done this yourself. You've created a factorial algorithm. So theoretically, you could go back and find your factorial algorithm and take a look at it, and it would help you solve this problem. Here's some things to think about when we think about this algorithm. The first thing is we need to be able to count the number of loops. So if we said what's the factorial of 5, we have to go 5, 4, 3, 2, 1. And so we need to be able to count that 5 times. We also need a variable to store the final answer. Like the final answer is not going to be 1. The final answer is going to be all of those numbers multiplied together. So we need something that's going to give us the answer. So we're going to have to set that up. And finally, the thing that we have to figure out is what math is needed. We're going through a loop, which means we're looking at each number one at a time. We're looking at the number 5. What do we do with that number 5? Then we are looking at the number 4. What do we do with that number 4? And we look at the number 3. What do we do with the number 3? So something's happening, and there's a pattern. And if you can solve that pattern in a loop fashion, then you can do really good math because you can have the computer do these loops, and it starts being really cool, the things you can do once you kind of understand that. So in this answer, the answer is that we need to multiply it one at a time, right? We need to multiply 5, and then we need to multiply the answer 5 times 4 and get 20, and then times 3 to get 60, and then times 2 to get 120, and then times 1 to get 120 still, right? So that final 1 doesn't really matter. So let's take a look at the algorithm, and I'll step you through this. First of all, in general, in pseudocode, you can say each line of this algorithm equals a line of code. So you can take this and you can start thinking through how would you code this in Python. So the first thing is that we need a number. This is where we say, okay, this is the answer. Maybe I should have called this answer, but I just typed in the word number. Usually, often you want that number to start at 0. Like if you're adding something, and you say, hey, what should I add? You kind of want to start the answer at 0. But in this case, this was kind of special, and so this number 1 is really important. And the reason is because we have to multiply. And if we end up multiplying things, if we made a number equal to 0, and then we later said multiply something by number, of course would equal 0, and then that would ruin everything. If I multiply by 1, and then I say, what number should I start with? It might say 5 times 1. And hey, then I get a 5, which means I get what I want to start with, right? So just by realizing the trick of multiplication, we can figure this line out. Then we could ask the user, hey, how many times do you want to do this? And that was from tip 1, right? We can keep on looping this as long as our count is greater than 1. Actually, I think the count should be greater than 0. But either way works because the number 1, of course, is just multiplied by 1. So it shouldn't affect the answer. And so this is the trick. We take the old answer, we take the number, and we say that number is currently 1, and we multiply it by the count. So if they said, I want to start my counting at 5, this would be 1 times 5, which would be 5. Store that answer in number. Decrease the count, so now count is 4. Come back up here, is 4 greater than 1? Yes, it is. The old number is 5 times 4 is 20. Store 20 into the answer. Count is at 4 right now. We subtract by 1. We get 3. Is 3 greater than 1? Yes, it is. So it's 20 times 3, which is 60. 3 minus 1 is 2. Is 2 greater than 1? Yes, it is. 60 times 2 is 120. Store that. 2 minus 1 is 1. Is 1 greater than 1? No, it's not. Skip this, print the latest number we have, which was 120. And so we had 5 factorial equals 120. So this loop, 6 lines of code, and inside the loop just two different things happening, can give us the answer to any factorial. Because now we could say count from 100 and give me 100 factorial, and it will do it because it will keep counting it 100 times. That's what computers are really good at. Computers are really good at loops because they can do these things like ridiculous numbers of times very quickly and come up with answers. That's what we love computers with math for. So hopefully that helps you out and gives you an idea of what to code.